Welcome to the start of a new unit. We're going to be learning about trigonometry in this unit, particularly how it relates to circles. In the past, you probably learned associated trigonometry with right triangles, and we're not going to be doing that in this particular unit. However, in a future unit, when you do trigonometry, it might be brought up again, probably more in your next math class. But we have to know what a radian is in order to understand some of the elements of trigonometry. A radian is, it's an angle, particularly an angle in a circle. And we're probably used to seeing angles in degrees. So it's another way to represent those degrees. Instead of calling it degrees, we use the radian symbol, and it's going to involve pi. And we talked about pi in a previous lesson. In a previous lesson, you may have seen something called a central angle. So in this case, let's say you have a central angle of 70 degrees. Well, eventually, if you go all the way around that circle, it would get to 360 degrees. And things can be done in degree mode, but 360 is quite a large number. Radians have a way of making those numbers smaller and more precise because when you calculate, let's say, an arc length or an area of the sector, you're inevitably going to involve pi. And pi is a messy decimal, and it's going to give you approximate answers if you don't write it in terms of pi. Radians help you write it in terms of pi a little bit easier, I think. So I think that's their purpose, and just to kind of make things a little bit smaller and easier to use. So a radian in a circle, if you take let's just take a circle here again. I'm gonna draw a new one. And let's say I draw a radius. Okay, we'll just call it R. The question is how many of these radii can I wrap around the circle? So if I were to take this radius and draw it again, but draw it up here, I might say, all right, I can draw that length. If I were to uncurve that, that would be approximately the length of this radius here. And if I drew another one, maybe that length there. And if I continued doing that, how many could we wrap around the entire circle? Take a guess at what you think it might be. I could use string and do this a little bit easier, right? But I'm just kind of eyeballing it right now. By my estimations, if I were just kind of do this without knowing the actual answer, because I know it, I would say there's a little bit over 6 radii that go around a circle. Well, the question is what is that additional amount, right? It's 6 point something, right? Turns out you can wrap approximately 6.28 radii around one circle. Now I want you to look at this 6.28. I can wrap 6.28 radii around one circle. And think about half the circle. All right, one circle is 360 degrees, or approximately 6.28 radii. Half the circle, that's 180 degrees. So I would expect that half of 6.28 would be the amount of radii that I can wrap around this circle. So 3 radii and a little bit more. Well, what is half of 6.28? Half of 6 is 3, half of 28 is 14. Should be about 3.14. Does that number ring a bell to you? It should, because this number represents approximately what the value of pi is. So I can wrap pi radii around half the circle, or 2 pi around the entire thing. So basically how this relates is a radius is the measure of a radian is the measure of an angle that is precisely opening up, that intercepts an arc that has the length of one radius. That's a mouthful. It's the measure of an angle that intercepts an arc that has the radius, that has a length equal to one radius. So like this here would be considered a radian. Now let's talk about this symbol. This symbol is called theta. It's a Greek letter. I don't remember what it stands for. I think it's capital T. But that's not important right now. We're going to refer to that as theta, and that usually represents the angle, usually in radians, okay? So I can fit, again, pi radians around half the circle. So what we'll say is 180 degrees is equal to pi radians. You could say 3.14 and make it a decimal, but we usually write it in terms of pi. So radians will be represented oftentimes as fractions of pi or 2 pi. So 360 degrees represents 2 pi radians. So think about the angles in between, you know. Let me draw a little circle here. And this is a good kind of introduction to what you're going to be doing in the next lesson anyway. If I go halfway around the circle, that's 180 degrees. That represents 1 pi. If I go all the way around, that's a full 360 degrees. That represents 2 pi. Well, what's half of pi? Pi divided by 2, which would be about 90 degrees. And you can make different fractions based off of pi. So this is the important thing we're going to look at today. You can use 360 equals 2 pi, but 360 divided by 2 is 180 anyway. So basically 1 radian, 1 pi radian is equal to 180 degrees. You can figure out the measure of what 1 radian equals if you wanted to. How you would do that is you would say, well, 180 degrees is 1 pi radian. And if my radius is, sorry for that pause there, my brain had a momentary lapse. Basically, to figure out what that degree is up here, what you would do, since 180 degrees is 1 pi radians, you could divide 180 by pi. And of course, pi is just 3.14. So if you pull up a calculator, and let me do that here. Let's do that on Desmos. You could say 180 divided by pi. Notice it gives you approximately 57.29 degrees. So that degree is equal to approximately 57.29 degrees. But we don't want to mess with those decimals. So we would typically say that is just going to be 180 over pi. As a radian, that would just be 1 radian, okay? Much easier to say than 57.29 degrees. So radians are typically measured in pi. And again, a radian is defined as the length or the measure of an angle that opens up to exactly an arc length of 1 radius. Now in the next video, I'll show you how to convert between radians and degrees and so forth.